From self-driving cars to virtual assistants, artificial intelligence, or AI is rapidly transforming our world. But what exactly is AI? In essence, AI is the endeavor of creating machines that can perform tasks that typically require human intelligence. These tasks include learning, problem-solving, and decision-making. Imagine a computer that can understand your questions, learn from its mistakes, and even write poetry. This field is driven by the quest to replicate the cognitive abilities of the human mind in machines. As we delve deeper into the world of AI, we'll uncover its inner workings, explore its real-world applications, and ponder its profound implications for the future of humanity. When we talk about AI today, we're often referring to a specific type known as narrow AI, also called weak AI. This form of AI excels at performing specific tasks, usually with a level of proficiency that surpasses human capabilities. Think of the chess-playing computer that can outmaneuver even grandmasters, or the spam filter that keeps your inbox free of unwanted messages. Narrow AI systems are designed to be masters of their designated domains. They learn from vast data sets and use algorithms to identify patterns and make predictions within those specific areas. Despite their limitations, narrow AI systems have revolutionized numerous industries. From healthcare to finance, transportation to entertainment, these specialized AI tools are automating tasks, improving efficiency, and even creating new possibilities. While narrow AI focuses on specific tasks, the ultimate goal for many AI researchers is to create general AI, also known as strong AI or artificial general intelligence. This represents the holy grail of AI development, a machine capable of understanding, learning, and applying knowledge across a wide range of tasks, just like a human being. Imagine an AI system that can not only play chess at a championship level, but also compose symphonies, write screenplays, and engage in meaningful conversations about philosophy. However, the path to general AI is fraught with challenges. Replicating the full spectrum of human cognition, with its ability to reason abstractly, understand emotions, and navigate the complexities of the real world remains a monumental task. Despite these hurdles, the pursuit of general AI continues to captivate the imaginations of scientists and engineers worldwide. At the heart of every AI system lies a fundamental ingredient: data. Just as humans learn from experiences, AI systems learn from data. The quality and quantity of data are paramount to the success of any AI system. The more data an AI is fed, the more it learns, and the better it becomes at performing its designated tasks. For example, a language translation AI needs to be trained on massive data sets of text in multiple languages to learn the nuances of grammar, syntax, and vocabulary. Similarly, a self-driving car relies on data from sensors, cameras, and GPS to navigate roads, avoid obstacles, and make split-second decisions. Section 5. Algorithms, the recipes of intelligence. Data alone is not enough to create an AI system. We need a set of instructions that tell the AI how to process that data, make decisions, and take actions. These instructions are known as algorithms. Think of algorithms as recipes for intelligence. Just as a recipe guides a chef in combining ingredients in the right proportions and order, algorithms guide AI systems in processing data and producing desired outcomes. The choice of algorithm depends on the specific problem the AI is designed to solve and the nature of the data being used. Section 6. Machine learning, teaching computers to learn. One of the most powerful tools in the AI arsenal is machine learning. This branch of AI focuses on enabling computers to learn from data without explicit programming. Instead of being explicitly told what to do, machine learning algorithms learn to identify patterns and make predictions from data. Imagine teaching a child to ride a bike. You wouldn't give them a step-by-step manual. Instead, you'd let them experiment, fall, and learn from their mistakes. Machine learning works in a similar way. There are various types of machine learning, including supervised learning. The AI is trained on labeled data where the desired output is already known. Unsupervised learning. The AI is presented with unlabeled data and must discover patterns and relationships on its own. Reinforcement learning. The AI learns through trial and error, receiving rewards for desired actions and penalties for undesirable ones. Section 7. Deep learning. Unlocking the power of neural networks. Deep learning is a subfield of machine learning that has gained significant traction in recent years. It involves training artificial neural networks, which are inspired by the structure and function of the human brain. These networks consist of layers of interconnected nodes or neurons that process information and pass it along to other layers. Deep learning excels at tasks involving vast amounts of unstructured data, such as images, audio, and text. For example, deep learning powers the facial recognition technology used in smartphones and social media platforms. The power of deep learning lies in its ability to automatically learn hierarchical representations of data, extracting increasingly abstract features as information flows through the network. Section 8: AI in our world, from voice assistants to self-driving cars. The impact of AI is no longer a futuristic concept. It's woven into the fabric of our daily lives. One of the most ubiquitous examples of AI is voice assistants, such as Siri, Alexa, and Google Assistant. These intelligent agents reside within our smartphones, smart speakers, and other devices, ready to answer our questions, set reminders, play music, and even control our smart homes with voice commands. Social media platforms are also heavily reliant on AI algorithms. These algorithms curate our news feeds, personalize our recommendations, target us with advertisements, and even detect and filter inappropriate content. In the realm of transportation, self-driving cars are rapidly advancing, promising to revolutionize the way we commute, travel, and transport goods. These vehicles rely on a suite of sensors, cameras, and AI algorithms to perceive their surroundings, make navigation decisions, and operate safely without human intervention. Section 9: The promise and peril of AI benefits and ethical concerns. The rapid advancement of AI brings with it a mix of excitement and apprehension. On the one hand, AI has the potential to solve some of the world's most pressing problems, improve our quality of life, and unlock new frontiers of scientific discovery. In healthcare, AI is being used to develop new drugs, diagnose diseases earlier and more accurately, and personalize treatment plans. In agriculture, AI-powered systems are optimizing crop yields, reducing waste, and promoting sustainable farming practices. AI can also play a crucial role in addressing climate change. By analyzing vast datasets of environmental data, AI can help us understand climate patterns, predict extreme weather events, and develop strategies to mitigate our impact on the planet. However, the development and deployment of AI also raise ethical concerns that must be carefully considered. One concern is the potential for job displacement, as AI systems become increasingly capable of automating tasks previously performed by humans. Another concern is the issue of bias in AI algorithms. Section 10: Gazing into the crystal ball, the future of AI. Predicting the future of AI is a daunting task, as this rapidly evolving field constantly pushes the boundaries of what's possible. One area of intense research is artificial general intelligence, which aims to create AI systems that possess the same cognitive abilities as humans. While AGI remains a distant goal, progress in areas like deep learning and reinforcement learning is bringing us closer to this ambition. Another promising avenue is the development of explainable AI. As AI systems become more complex, understanding their decision-making processes becomes increasingly challenging. XAI aims to create AI systems that can provide transparent and understandable explanations for their actions, fostering trust and accountability. The convergence of AI with other transformative technologies, such as quantum computing, biotechnology, and nanotechnology, is also poised to revolutionize various industries. As AI becomes increasingly integrated into our lives, it's crucial to consider its societal implications. Section 11: A new era of intelligence, embracing the possibilities. The journey of AI has just begun. As we stand at the cusp of a new era of intelligence, it's both exhilarating and daunting to contemplate the profound implications of this transformative technology. From automating tasks to augmenting human capabilities, AI has the potential to reshape our world in ways we can only begin to imagine. It's a tool that can be used for good or ill, and it's our responsibility to ensure that its development and deployment are guided by ethical principles and a commitment to the betterment of humanity. Let us embrace the possibilities with open minds and a shared commitment to shaping an AI-powered future that benefits all of humanity.